No doubt you have noticed that on just one series circuit with a 9-volt power supply, you can't get that many LEDs. So the big question is, you want to have many LEDs of 9 volts, not just a couple. Is it possible? Well, the answer is yes. So what you do, you build multiple series circuits, and then you combine them to form a parallel circuit. So let me show you. Here I have one series circuit of 2 blue LEDs, each consuming 3.2 volts. So that is a total of 6.4 volts. Now, from this end to this end, we are using up 9 volts. That is what the battery is supplying. So therefore, we've got 9 volts minus 6.4 volts. That means the leftover is 9 minus 6.4, which is 2.6 volts. And then to work out the resistances I need for my resistors, I just use Ohm's law again. And in this case, it would be 2.6 volts divided by 0.02, and that becomes 52 ohms, I believe. Let me just double check that with the calculator. So 2.6 divided by 0.02 equals, oh, sorry, I can't count. It is actually 130 ohms. There. So what you would do, that means because we have an odd number of resistance, you might get a 100 ohm resistor here, plus a 30 ohm resistor. And if you don't get 30 ohm resistors, then you get a 10 ohm resistor plus a 20 ohm resistor. So as long as you get a total up about 130 ohms. Now down here, the same situation goes on, right? We just add up the total resistance of the LEDs. All these 4 red LEDs are using 2 volts each at optimum forward voltage. Therefore, that is a total of 8 volts. And therefore, we have, because we've got a battery supply of 9 volts, therefore 9 minus 8 volts is 1 volt. So therefore, this resistor is going to use up 1 volt. And that means the resistance here is going to be, using the same formula, resistance equals voltage divided by current, which is 1 volt divided by 0.02. And I believe that's going to be 50 ohms. So 1 divided by 0.02. Do that again. 1 divided by 0.202, 50 ohms. All right, and so you should get like a 47 ohm resistor, and that will do the job. Now down here we have a blue LED, a green LED, and a red LED again. So here we have a multicolored circuit. These two are monocolors, blues and reds. So let's combine this and work it out. We have a total here of 6.2 plus 2, 8.2 volts used up by this part of the circuit. Therefore, we have left over 9 minus 8.2, which is 0.8 volts used up. Therefore, the resistor I need is V divided by I, which equals 0.8 divided by 0.02. And let me calculate that again. 0.8 divided by 0.02 is 40 ohms. So this resistor will be 40 ohms. Same thing again, if you can't get a 40 ohm resistor, you just add a 30 to a 10 or whatever. So approximately 40 ohms. And now, to answer the big question again, can I have many LEDs? And this is what you do. You just combine these circuits. So now I'll combine them. And then you just have this going to your negative of your battery. And you combine these two. and this goes to the positive terminal of your battery. So in terms of current flow, it's worth knowing this too as well. This part of the circuit has 20 milliamps flowing through it, all along here, 20 milliamps. This whole part of the circuit is also using 20 milliamps of current. And this part of the circuit is also using 20 milliamps of current. So therefore, the total current will be 20 plus 20 plus 20 is 60 milliamps. And of course over here, 60 milliamps too. So that's how you do it. Now obviously, because you've got more LEDs, you'll be using up more battery power faster. So your battery will last, have a shorter life. And these are 9-volt batteries we're talking about. And of course, don't forget the switch. And the place to put the switch could be over here or over here.